Welcome to EDU World Space.
So most people are familiar with Kepler's first law, which says that planets orbit the sun in elliptical orbits. Most people are also familiar with what's called the standard form of the elliptical equation, which is x squared over a squared plus y squared over b squared is equal to 1. So this is about looking at this equation and interpreting what this equation looks like on a plot. What does the ellipse do? And so we can rearrange this equation. So what we're going to be doing is solving for one of the variables, let's say x. And that's fairly easy to do with some algebra. X squared over a squared equals 1 minus y squared over b squared, and then separate it. And take a square root. It's as simple as that. We'll start with the x, and of course taking a square root means that we get a positive and negative root. But if we look at this equation, what we see is that x has a maximum value, has a maximum plus value when y equals 0. And the way we can see that is the stuff in the square root, because it is 1 minus something that is always positive. What we can say then is that we always have something less than 1 in that square root, and so less than or equal to 1. And so it's equal to 1 when y is equal to 0. And then we can also take the obverse. X has a minimum minus a when y equals to 0. So x is double valued, and we can make a plot of that on a xy plot. So we know that x is stuck between a and minus a. We could do a very similar thing for the y values as well, is that, if we solve for y, I don't need to go through all those steps again, but we have y is equal to plus or minus b times 1 minus x squared over a squared to the 1/2. And again, we can see that y, as long as it's real, is going to be stuck between y has a max equal to plus b when x equals 0. And it also has a minimum at minus b when x equals 0. So again, the y is double valued in terms of having two places where x is equal to 0. And here we're going to assume that b is less than a. And we know that the points in between are less than the max or greater than the min. So it says that the curve has to do something in between. Now, showing it's identical to an ellipse is a little bit tricky, but I don't think the problem is asking for that to develop a conic section equation and look for the foci and all that kind of thing. Hopefully we aren't going to be doing that in this problem. But we do have a general sense of that the curve is symmetric about the 0, 0 point, and that there are two axes, one along the x centered at 0 and stuck between minus a and a. So we can interpret the half the axis as the semimajor axis, and the semiminor axis is equal to b.